Good morning, sir.
Good morning. Good morning. Okay, so good morning to all. Okay, so yesterday in the first class, we have just uh, had a basic, or you can say an introductory session, or a brief idea of the particular subject. Okay, so this subject is actually the electromagnetic field theory. Okay, so and we have seen that we have just started the first module, okay, which is the coordinate systems. So we have gone through the basic discussion regarding the vectors and the example of vectors and difference between vector and scalar. Okay, then we have seen that in this particular chapter we will be going through, or we will be getting introduced to three coordinate systems. Okay, one was the rectangular coordinate system, or which is also called the Cartesian coordinate system. Next is the spherical coordinate system, cylindrical coordinate system, and then we have the spherical coordinate system. Okay, so rectangular or Cartesian coordinate system. So in the last class we had a brief discussion regarding this particular coordinate system. We have seen that this coordinate system is an orthogonal system, because all the three coordinate systems that we are going to study are all actually right-handed orthogonal systems. That means all the axes which are there, because these coordinate systems are actually three-dimensional. So whatever coordinate system you choose out of these three, that is Cartesian, cylindrical as well as spherical, all these coordinate systems will be the orthogonal actually, because these axes which are there, three axes are there, all are right angle to each other. Okay, that means perpendicular to each other. That means in Cartesian coordinate system we have seen we have three axes. One is the x-axis, one is the y-axis, one is the z-axis. So in Cartesian coordinate system these three axes are perpendicular to each other. Now whenever you have to locate any point, okay, on the axis, which we have just seen in this particular figure, okay, that means in figure number 8 we have seen that any particular point can be represented, okay, can be represented by using the with the help of Cartesian coordinate system. We have to first locate the x coordinate first, okay, then the y coordinate, then the z coordinate. Accordingly we have to do. Now, okay, 1 second, someone is trying to join. Okay, so in this particular coordinate system, as we have discussed in the last class, that the any particular scalar point can be located like this. Okay, now in this coordinate system, okay, we also generally locate vectors along with scalars also, because we have to locate vectors. Now vectors, we all know they have magnitude as well as direction. Okay, now this magnitude means, direction means basically these three axes which are there, x, y and z, these three axes are actually are also representing the directions, because x is directed in this way, in this path, so its direction is along this path. It is not like that it is passing somewhere from here or making some angle like this. No, x will be always along this direction, okay, particular along this direction. Y axis will be perpendicular to x and z will be perpendicular to both x and y. It will be pointed upwards. That means these axes have their own unit vectors. That means you can see this a suffix x, a suffix y, a suffix z, these are all the unit vectors. Unit vector means, unit vector is a vector which is obviously having a direction but magnitude of 1, unity. That means it only helps you to understand that in which direction the vector is directed or oriented, in which way it is directed. Okay, if it is a x-axis, okay, so x-axis direction is over like this, so it will be represented like this using this unit vector. Okay, suppose you have a vector and you are putting you are drawing a vector like this, say 5. So 5 is the magnitude. That means it will, this magnitude whole length is 5, but direction is along x-axis. Okay, So we will call it, suppose this is a vector A, so we will call it 5 unit vector x. A suffix x is the unit vector. Okay, so it means that the vector is directed along x axis. If you have a vector like this, say 7, then it will be represented like this, y. If it is like this, say 8, so 8 unit vector z. Now there are few vectors which are directed like this. So they are the summation of either 2 coordinates or more than 2 coordinates. Hello, am I audible? Okay, so there was actually some network issue. Okay, wait, let me share the screen. Now I think it is visible. Okay, wait. Okay, so now it is visible. So as I was discussing that this particular axis, okay, this x axis, y axis and z axis, these are all actually directions. So a vector, if you want to plot a vector, say vector A, it is having magnitude 5 and it is along the direction x axis. So it will, you have to mention that how will you represent that this vector is along x axis. You have to associate with it by using this particular unit vector. Okay, so this ax is the unit vector which is having magnitude 1 and direction along the x axis. Ay is the unit vector of y axis, az is the unit vector of z axis. So A7, ay is a vector which is along the y axis and magnitude 7. 8 az, that means 8 unit vector z is a vector which is along the z axis and magnitude 8. But some vectors are like this, suppose, which is not oriented towards any particular axis. The direction is not along x or y or z. The direction is somewhere in the midway. That means this vector is a combination of either 2 or 3 axes. So vector can be like this. Say 2 unit vector x plus 5 unit vector y plus 7 unit vector z. That means it is having 2, 5 and 7 and direction is somewhere like this. Okay, it can be represented in this way. So this is a way of representing a vector in a Cartesian coordinate system. If you see this particular slide, wait once again. Here, see, a vector A in Cartesian coordinate system is written like this. Okay, that means this is nothing but the scalar part, and whenever you convert into a vector, then what happens? With every corresponding coordinate, one unit vector is associated. You can see one unit vector associated. Here also we have az, here also we have az, but here we are multiplying with small az. That means the unit vector. Okay, that means this is a vector. So vector is always represented in this way. So it can be simple like this. Only ax, ay and az, that means unit vector y and unit vector z will not be there. Yes, it is possible. If you see this particular vector a, then 5x, where 5 is the capital Ax and the small ax is the unit vector which is representing that the vector is along the x axis. Okay, but for this case, if it is comprising of all the 3 axes, then you have to represent it in this way. It can be only one, it can be summation of any two, a y or a plus z or y plus z, or it can be summation of all the three. Okay, that depends upon the vector. Okay. So now this limit we have already discussed in the last class. Okay, that means this axis will be, there is no particular limit, because this how much length or at what point you can locate a particular particular scalar or vector. Okay, there is no limit to it. That means in all the three axes the limit is minus infinity to plus infinity, and the unit or base vectors, that is the unit vectors x, y and z, the following relation holds. Now one important thing, once you discuss our vectors, always the relationship comes that multiplication, addition and subtraction, these things comes. Okay, that means suppose if I tell you that we have a vector a, okay, and then is another vector a dash, which is having 2 unit vector x. So obviously you will add them and you will get a vector 7 unit vector x. Okay, also you can add one vector with another vector to get a third vector, that is also possible. But in generally in coordinate systems we come across multiplication in most cases. Okay, that means if I discuss about, suppose you forget about all these things. Okay, you forget about all these things. Suppose we concentrate on this particular coordinate systems and these what do you say, the unit vectors, unit vector x, unit vector y and unit vector z. You have 3 unit vectors, they are directing the corresponding axis. Okay, now the unit vector x is there. Now suppose you take this vector unit vector x and you dot product with itself, because it is a vector, so we can perform this dot product and cross product. Now tell me, if you take two vectors, suppose vector a and vector b, and if you take a dot product, then what is the equation? Can anyone please tell? What will be the solution? If you take any two vectors and if you perform the dot product, what you will get?
Sir, AB cos theta.
AB cos theta, but A will be magnitude of A. Okay, it will be magnitude of A, magnitude of B, then cos theta. Cos theta means, where is theta? Theta is the angle between the two vectors. This is vector A and this is vector B, and the angle is theta. So whatever will be the angle will be theta. Now tell me, will the result be a scalar or a vector?
A scalar, sir.
Scalar. So the result will be a scalar, because dot product always gives you a scalar. Dot product will always give you a scalar. Okay. So if you perform unit vector x dot unit vector x, so what you get? What will be the solution? That means you are performing the dot product operator with the unit vector itself, unit vector x itself. Then what will be the solution?
1, sir.
1. Why? Please explain.
The unit vector होता है sir.
One by one, please. Repeat.
Sir, cos 0 equal to 1.
Cos 0 equals to 1. So that means the solution will be, if I use this particular equation, then magnitude of unit vector x, because this is also a vector, magnitude of unit vector y and cos theta. Now the magnitude of unit vector will be 1, because unit vector means magnitude 1. So both the unit vectors will sorry, this is x, sorry, my mistake, it is x. So the unit vector x is having magnitude 1. Now cos means the angle between unit vector x and itself is obviously 0. So cos 0. So cos 0, 0 degree will give you 1. So it will be 1. So that means if you take any unit vector, say y dot y, then also you will get 1. If you take z dot z, then also you will get 1. Okay? Then also you will get 1. Okay. Now suppose if I perform now the other way around, suppose unit vector x dot unit vector y, then what you will get? This will also be a scalar. Then what you will get? That means dot product.
0.
Yes, 0. So dot product between unit vector x and y will be 0. Why? Because once again unit vector magnitude of unit vector x, magnitude of unit vector y, cos. Now the angle between them are 90 degree. So magnitude 1 dot magnitude 1 dot 0, cos 90 is 0. So it is 0. So that means if you take the cross product, a dot product between one vector, unit vector of one axis with the other axis, it will always be 0. Okay? It will always be 0. It will always be 0. Okay, so this thing you have to keep in mind. So this is the story of the dot product. Now, what about cross product? That means unit vector, once again I am just drawing over here the unit vectors. Okay, this is unit vector x, this is unit vector y, this is unit vector z. Okay, now unit vector x cross unit vector x, what you will get? Now tell me, what is the, first of all, before that, what is the equation? Because cross product, I am just repeating because these I have already studied in school level, but still I must repeat. A, B, two vectors, this is theta. Okay. Now dot product we have seen, but what about cross product? What will be the cross product?
AB
Huh?
Sir, magnitude of A, magnitude of B,
B
sin theta, or n cap, unit vector.
sin theta unit vector. Why unit vector?
सर क्रॉस प्रोडक्ट परपेंडिकुलर होता है सर, जो क्रॉस प्रोडक्ट का जो ये आता है मैग्नीट्यूड, वो उस पे परपेंडिकुलर होता है, तो परपेंडिकुलर हम लोग का यूनिट वेक्टर ही होता है.
हाँ, so because cross product of any two vectors gives you a third vector, and third vector will be directed perpendicular to both the vectors. That means if you are having two vectors A and B, it is not necessary that this A and B will be perpendicular to each other. They can have an angle theta, any angle, but the resultant vector, the third vector which you are getting, will be perpendicular to both the two. So it will be always either directed upwards or downwards. Generally it is directed upwards. We generally represent by using the right hand screw rule. That means cross product means you are crossing it, so directed upwards. If you are doing the opposite way, okay, then the direction will be downwards. Okay, so this is the cross product. So in our case, if you take A cross unit vector x cross unit vector x, so it will be magnitude into sine 0. So solution is 0. That means cross product of a unit vector with itself will give you 0. Okay, with itself will give you 0. Okay, now what about cross product of x, unit vector x and unit vector y? What will be the answer?
सर जेड, ए जेड.
Unit vector z. Why? Because the solution will be, if I show the steps one by one, that means magnitude of x, magnitude of unit vector y, sine 90 degree, and n cap. Now if a unit vector x and unit vector y are like these two, then the resultant will be this one. This is actually n cap. So n cap is nothing but it is actually the unit vector z, because this is 1, this is 1, now sine 90 is also 1, so it is 1 dot 1 dot 1, n cap is az, so it is az. That means unit vector z. That means if you take the cross product of any two vectors, then you will get the third vector. Okay, you will get the third vector. Okay. So this is the concept of cross product of in the Cartesian coordinate system. So the cross product of any two vectors will give you the third vector, and dot product of any two vectors will be 0. And one more thing, if you take the cross product of a vector with itself, you will get 1. You will get 0, and dot product with itself will give 1. Okay. Now coming to another discussion, that is the differential length, area and volume in Cartesian coordinate system. Differential length, area and volume. Suppose you have, okay, let me show you, wait, in the next slide. I think this is not okay. Suppose we have this Cartesian coordinate system, x, y, z plane. Okay. This is z plane, this is z axis, this is x axis, and this is y axis. Now if you have a point P over here, okay. Now point P, if you draw the dotted line like this, okay, so suppose it is having some x coordinate, it is having some y coordinate, it is having some z coordinate. Okay, suppose point P, I am not writing over here, just writing in the side. Suppose it is having x1, y1 and z1. Okay, values x1, y1, comma z1. Okay, these values are there. Now if I take another point Q, okay, which is having, suppose like these values, and Q is x2, y2, z2. Okay, now it is observed that x2 is greater than x1, y2 is greater than y1, and z2 is greater than z1. Suppose the x1 value are 1, 2, 3, point P, suppose, then point Q is 4, 6, 8. So that means x2 minus x1 will give us delta x, that means difference. In this case it is 3. Okay, y2 minus y1 will give us delta y. In this case it is 4, and z2 minus z1 will give us delta z, which is 5 in our case. Okay, suppose that means to reach point Q we have to increase every coordinate by some value. That means to reach Q, okay, First of all, we have to increase by x. We have to increase by x like this, then y, then z. Suppose you are standing at P, you want to go to Q. You cannot go directly. You have to first travel along the x-axis, then y-axis, then z-axis. So this length is actually delta x. This length is delta y. This length is height is delta z. Okay, the difference, this one. So adding all these three, then you get the actual distance between P and Q across all the axes. This is called the differential length. Okay, that means first of all, if you discuss about the differential length, okay, talk about differential length. So delta x, suppose we call it dx. Okay, that means this is point P. I'm representing over here. This is point P. Suppose this is point P, and this is point Q. This one is point Q. This point. Now to travel from P to Q, you have to start sorry, the notation is wrong. Okay, suppose this point is P. Okay, this point is P. This is P. This middle one, I'm circling. This point is P. Okay, and this point is Q. This point. Okay, now to reach Q, we have to first travel along x-axis. That means this additional, this one is additional dx. Okay, then you have to travel along y-axis, additional dy. Okay, then we have to travel upwards, dz. If you extend this, we can draw a cube like this. So dx, dy, dz. So this length, now displacement is a vector. Now if you want to say that in which directions we have traveled three directions. Once we were traveling along x-axis, we have traveled along, means when we were traveling dx, we were traveling along x-axis. So dx unit vector x is the displacement of this part. Okay, then next displacement will be along y-axis. It will be dy unit vector y. Then the third displacement will be along the z-axis. So it will be dz unit vector z. So adding all the three, we get the total displacement. The total displacement made to reach Q from P by traveling all the axes. Okay, so this is called the differential length. Okay, so that means difference in the length. So we cannot take the shortcut. That means we cannot take the PQ like this. No, we have to travel along all the three axes. Okay, this is called the differential length. Now differential area is also there. Area means if you take, suppose this part. Okay, so we were getting some plane. Suppose this plane we are talking about, this is XY plane. Now previously our point was over here. This was the point. Now this Q point is over here. Are you getting? Let me repeat. Wait. We have started from P. This was P. This was P. And this is Q. This is Q. Now, to travel from P to Q, we have traveled first along x-axis, then y-axis. So that means this x-axis and y-axis we are traveling. So this additional plane we have to travel. This additional area we are getting. Why we are getting? Because P point was over here. This was P point. This was P point. And this is actually Q point. So if you extend it over here downwards, this is Q point. Okay, this is Q point. So that means in traveling from P to Q, we are getting this shadow. That means shadow of this cube. So we are getting some area. So in the differential area we are getting. So this is along x and y. So x, y we will have some area. Similarly, when we are traveling from y to z, we are getting this area. Okay. Okay, so we are getting this area, and we are also getting this area also from we can say from y to z we are getting two areas, this one and this one. So one at the top, one at the front, one at the side. So this entire cube is actually generated because of this displacement. So if displacement was not there, the cube would not be generated. So that similarly differential area is also created. So differential area will be dx dy. Dx dy is the area of the xy plane. Dy dz is the area of the yz plane. This one. And dx dz dx is the xz plane. Now you can see this particular in figure. You can see these arrows are given. ds xy, that means this differential area, but it is pointed upwards. Why? Because area is a vector. If you take the two axes, suppose x axis and y axis, if you draw the area, okay, then area will be a vector and resultant vector will be perpendicular, normal. So this is the xy plane, this one is the xy plane, okay, same thing, this one. So its direction is upwards. So upward means z axis, normal means this, normal means z axis. That is why this, if you multiply dx and dy, if you find the area of xy plane, then xy plane area will be a vector, because differential displacement is a vector, area is also a vector, okay, but volume is a scalar. So this thing you have to understand. So similarly in differential length we have represented by dx unit vector x, dy unit vector y plus dz unit vector z. So we have represented over here. In area, when we take the area of the two planes x and y, then the resultant will be z axis. If we take the area of y and z, that means y and z means this one, y and z, this plane. So the distance will be, a direction will be along x axis. And if you take the area of z and x and z, so the vector will be along y axis. Okay, so this is the differential area elements. So there are three differential areas. Unlike displacement, we have only one, but area there are three. So it is represented as ds rectangular, but this is called ds xy. This is ds yz. This is ds zx or xz, whatever. It is zx actually. Okay. Now differential volume, because if you have an area, then obviously if you multiply all of them, you will have volume, isn't it? So volume matlab just get the multiply all the three differential lengths, okay, dx dy dz, because volume is a scalar. You multiply because it cannot have a direction, because there is no normal, because volume is three dimensionally, we are multiplying everything and we are consolidated into one. That is why it is a scalar. So dx dy dz is a scalar. So this is called the differential volume. That means from point P to point Q, when we are traveling, we are creating a volume also. That is why it is called the differential volume. Understood? Did you get this point?
Yes, sir.
Students, so if you have a question, you can ask. So did you understand that? I think this is quite easy, because the dot product and cross product relationship between the unit vectors quite easy. And then this is how it is represented, that if you are traveling from one point to another, then actually you are traveling through all the axes. So you cannot jump. You have to travel through all the axes. First x-axis, y-axis, z-axis. Now when you're traveling, you're actually making a displacement. So it is a vector. So dx unit vector x plus dy unit vector y plus dz unit vector z. So you're traveling like this. If you travel, you get a total displacement. That is summation of the individual unit vectors. So get a total vector. So dl is this vector. So it is not having a unit vector. Okay, you cannot say that what is the resultant vector of dl. No, because the summation of all the vectors is the resultant. Because it is not having a single unit vector. It is a summation of the total, all the three axes. So generally vector is represented like this in Cartesian coordinate system. Okay, but in area we will have a unit vector. Okay, because it is directed perpendicular to the plane. So whenever you have a plane, suppose xy plane, so that area we will write, say whatever x and y, whatever value you have, you multiply, but resultant will be along z. Okay, and volume you have to multiply all the three because volume is a scalar quantity. Okay, so any questions from this topic from your side? Okay, so if you are unable to understand, then you can please let me know. You can interrupt me anytime. Okay, so I am ending today's lecture up to here. Okay, because in the next class we will discuss regarding the next coordinate system, and then we will come across some numericals so that you will be able to understand better. Okay. Okay, so if you have any questions, you can ask. So I will.
Sir, notes.
What? Please repeat.
Notes.
Notes. I will share the notes. Okay, I will share the notes later. Okay.
Sir, where will you will share?
I have a Google Classroom, so I will share the Google Classroom code. For that, I have to speak to the person who is actually, because I don't. You are actually not added to a WhatsApp group of the faculties. Okay, or the other students. I think you are getting the information from the Pulosto Saras, I think, from the admission cell. Okay. So I will ask him. I will ask him regarding what is the procedure, and then accordingly I will share or via him I can share you the Google Classroom code. So using the Google Classroom code, you can enter the classroom. Okay. I think all of you are familiar with Google Classroom. Okay. So
Yes, sir.
so just enter the code and you will get the access, and you can see the notes are already there. Okay. Okay, so I will talk to the admission department, and then I will share it to them, and they will be sharing with you. Okay.
Sir, any reference book can you
सर
suggest?
only this subject or
No, whatever subject I am taking, I will be sharing. So for other subjects, you have to talk to the other those respective subject teachers. Okay. Reference book. Reference book.
Okay, sir. Okay.
One reference book is also shared with the in the Google Classroom. Okay. So okay, so you will get the reference book over there also. Okay. So I will talk to the admission cell by today.
Okay, sir.
So again, we are having class tomorrow, so no problem. You can join, and we will have continue our discussion over there tomorrow also. Okay. Okay. So thank you, students. Then.
Thank you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.